Hello everyone, I hope you're all doing well. In this video, we will cover the second half of our A levels chemistry P1 2024 paper, and let's start with question number 21. Alright, so this question is about two salts, sodium iodide and chloride. The two solid salts are separately added to warm concentrated sulfuric acid. So first of all, we will check that how these two will react with sulfuric acid. And the aqueous solution of two salts are separately added to silver nitrate and concentrated ammonia is then added, and the results are noted. Which row is correct? So first of all, we need to know that whether sodium chloride and sodium iodide when these will react with sulfuric acid, whether these will form these products or not. So this is our first part of this question, and the second part is if you will add this solution into silver nitrate, and then if you will add ammonia, aqueous ammonia into that solution, then we will check that whether you will get these observations or not. So as we know that our halides, because we are dealing with chloride and iodide, our halides are strong reducing agent, especially when you will move from top to bottom. So this is the trend in the of their strength of reducing power. So iodide is the strongest reducing agent, bromide is weaker than iodide, and chloride is a very weak reducing agent. So when you will add these into sulfuric acid, chloride cannot reduce sulfur. As you can see that sulfur has positive 6 charge. So sulfur has positive 6 charge, and this will sodium bisulfate will also have positive 6 charge when you will react it with chloride containing salt. So when you are reacting chloride containing salt with sulfuric acid, there is no change in the oxidation number. It's mean that this is not a redox reaction. So if chloride will not reduce sulfur, it will not act as a reducing agent. So we know that reducing agent is the one which will reduce other and oxidize itself. So it is not going to oxidize itself into chlorine, Cl2. This is what they are asking in the option A, that sodium chloride, when you will react with sulfuric acid, it will convert into chlorine. No, that is not going to happen. So this is the wrong option. Then if you will add iodide into sulfuric acid, iodide being a very strong reducing agent can reduce sulfur into sulfur dioxide, which has +4 charge, or sulfur, which has no charge, or hydrogen sulfide, which is -2 charge. It's mean that the oxidation number of sulfur is changed from +6 to +4. It means that it is reduced. The oxidation number is decreasing. It's mean that it is reduced from +6 to sulfur 0 and -2. So these all are giving us information that iodide ion is reducing sulfur of sulfuric acid into these ions. So iodide can reduce sulfuric acid into H2S, and it can also convert can also give this product iodine. When it will reduce other, it will oxidize itself into iodine molecule. So these both points are correct. Now the second part was the observation after silver nitrate and ammonia are added. So when you will add silver nitrate into these halides containing salt, then if there is chloride, you will get white pipetties, and if there is iodide, you will get yellow pipetties. And we know that on further adding ammonia, if you will add dilute ammonia, this white pipetty will dissolve. If you will add concentrated ammonia, the cream pipetties of bromide can dissolve, and the pipetties, precipitates of iodide, like because of the silver iodide, those yellow colored precipitates will not dissolve in either dilute ammonia or concentrated ammonia. So when you will get precipitates of iodine, because of the silver iodide, these yellow colored precipitates will not dissolve on adding ammonia. So it's mean that these will remain as it is. So that is why the option C is the correct option. Question number 22. The diagram shows the process of adding calcium nitrate and strontium nitrate to two separate boiling tubes. So we have two boiling tubes, these two, and we are adding these two salts in these tubes and using identical condition. As the reaction proceeds, the water containing universal indicator changes color. So we have this universal indicator, which is of green color, which row describes the color change and identifies the nitrates that causes the quickest color change. So first column shows that find out that what would be the color change in of universal indicator. Now we know that these two, calcium and strontium, both of these belongs to group 2. So these are group 2 metal nitrates, and we know that when you will heat group 2 metal nitrate, after thermal decomposition, these metal nitrates will produce metal oxide, nitrogen dioxide, and oxygen. And metal oxide will be solid. Metal oxide and nitrogen dioxide and oxygen, these two are gases. So we will get these two gases here in these two tubes. And when these two gases will transferred into this universal indicator, the universal indicator will turns acidic. Why? One thing is, one gas is oxygen, that will definitely not change the color of universal indicator, but nitrogen dioxide, which is an acidic gas, as it is non-metallic oxide, and non-metallic oxides are acidic. So when it will dissolve in water, it will produce nitric acid, and it will react with water to produce nitric acid and nitrous acid. So that is why the color will change of universal indicator will change from green to red. So option C or D could be the correct option. The second column is nitrate that causes the quickest color change. So the one from these two, calcium or strontium nitrate, that will react fastly, that will definitely change the color of universal indicator in less time period. So as these two belongs to group 2, so we know that group 2 elements are beryllium, magnesium, calcium, strontium, barium, and radium. And there is a trend in the thermal stability of metal, these group 2 metal nitrate, that is that from top to bottom the group 2 metal nitrates will become more thermally stable. So strontium is more stable as compared to calcium. So strontium nitrate will decompose if you will provide more heat. So it's mean that it will take more time to decompose into nitrogen dioxide and strontium oxide. So that is why it will give us a slow reaction, but calcium nitrate will decompose easily, and that is why it will produce it will change the universal indicator color in less time period. So option C would be the correct option. Number 23. The equation for these three reactions involving chlorine or its compounds are listed. Now which statement about this equation is correct? Equation 1 describes the formation of a compound used to kill bacteria in drinking water. So the compound which is responsible to kill the bacteria in water is hypochlorous acid. When you will perform chlorination of water, in result this compound will form, and further when this compound will split, it will break, it will basically make two compounds, two substances. One is hydrochloric acid and the other one is nascent oxygen, atomic oxygen, which is very reactive, and this is the main substance which is responsible to kill bacteria. So here in this equation 1 we are having potassium chloride and oxygen, which is molecular oxygen, so that is why option A is incorrect. Now equation 1 does not represent a redox reaction. Okay, now what is redox reaction? The reaction where both processes are happening, oxidation and reduction. So chlorine, which has potassium has +1 charge, oxygen has -2 charge, there are 3 oxygen, so it will become -6, and chlorine has +5 charge. And in potassium chloride, chlorine has -1 charge and potassium has +1 charge, and molecular oxygen in its elemental form will have no charge. So what is happening in this reaction is that chlorine is changed from +5 to -1. It's mean that it is reduced because oxidation number is decreased, and oxygen from -2 to 0, its oxidation number is increased, that is why it is oxidized. So both of these reactions are happened in equation 1, that is why this will be a redox reaction. So this equation is incorrect because they are saying that their equation 1 does not represent, so it does represent a redox reaction. Then option C, equation 2 describes the formation of potassium chlorate 4. So this is our equation 2, and here we have KClO4. So they are saying that formation of potassium chlorate 4. So we will see that it is potassium chlorate. The name of this compound is potassium chlorate, but we will check whether the chlorine has +4 oxidation state or not. So you can see that there are 4 oxygen, and all 4 oxygens will have -8 charge. Potassium will have +1 charge, and what would be the charge on chlorine? It would be +7. So there must be 7 in this in these brackets. So that is why this option is also incorrect. Equation 2 and 3 both represents the disproportionation reactions. Now what is disproportionation reaction? You all are pretty familiar with this word, that the reaction in which one atom, the element, will oxidize and that same element will also reduce. So for example, in this equation, in equation 2 and 3, in equation 2 chlorine has plus, what would be the charge in chlorine? That potassium has +1 charge, -6 would be on oxygen, so chlorine should have +5 charge. So chlorine is changed from +5 to +7, its oxidation number is increased, so this shows oxidation reaction. And in potassium chloride, chlorine has -1 charge, so that is why it is reduced. So the same atom, chlorine, is oxidized and reduced, so this equation shows disproportionation reaction. So this is confirmed. Then equation 3, where chlorine has 0 charge because it is in its elemental form, so there is no charge in elemental form, and chlorine has -1 charge in potassium chloride, and -6 +1 and +5 charge in potassium chloride. So from 0 to 5 and 0 to -1, it means that chlorine is oxidized and reduced in equation 3 as well. So the option D, where they were saying that equation 2 and 3 both represents the disproportionation reaction, this option is the correct option. Question number 24. Nitrogen monoxide is a primary pollutant produced by petrol engine and is found in their exhaust gases. Which reaction occurs in the catalytic converter and decreases the emission of nitrogen monoxide? Now, as you know already, that the purpose of catalytic converter is that it used to convert more harmful gases into less harmful gases. So nitrogen monoxide is a harmful gas, acidic gas, so you want to convert it into less harmful gas. So nitrogen dioxide, nitrogen dioxide, nitrogen dioxide, and as you know that nitrogen dioxide is also an acidic gas. So when it will combine with water molecule in your atmosphere, that can produce nitric acid. So, and that is in result the acidic rain will form. So nitrogen is the only product which is not harmful. So we want to convert nitrogen monoxide into nitrogen. So nitrogen monoxide will reduce into nitrogen, and the carbon monoxide will act as a reducing agent. So it is a reducing agent, so obviously it will oxidize itself. So it will oxidize itself and it will convert itself into carbon dioxide. So the option C is only correct option. Question number 25. The diagram shows the structure of naturally occurring molecule cholesterol. Student X stated that the 17 carbon atoms in the 4 rings all lie in the same plane, and student Y stated that the molecules displays this trans isomerism at this carbon double bond carbon. Which student are correct? Okay, so the first student is saying that all carbon atoms lie on the same plane. So just keep it in mind that sp, sp2 and sp3 hybridization, from these 3 hybridization of an atom, especially carbon atom, only this one is linear, this one is trigonal, but and it is a trigonal shape, but it can exist in one plane. Like you can place these three atoms which are having sp2 hybridization on this one single plane. But sp3 hybridization, the geometry of sp3 hybridized atom was that it will arrange four atoms are attached directly to the central atom with 109.5 degree angle, and the geometry of this molecule would be tetrahedral. And in tetrahedral shape, at least one atom will be out of the plane. So you have to draw. That is why when you will draw your tetrahedral shape, you need to draw it in this way, that at least one bond will be drawn by the dotted line. It means that it is away from you, and the other bond will be wedge shape, and it means that it is towards you. Like these two atoms are on same plane. This one is away from you and this is towards you. So these all four atoms are not on the same plane. And in these rings, most of the atom, other than these carbon double bond carbon, most of the atoms are sp3 hybridized. These are directly attached with 4 atoms. Like this carbon atom is attached with one carbon, second carbon, and two hydrogen atom. So if any atom is making 4 single covalent bond, it means that it is sp3 hybridized, especially for carbon atom. So all of these are sp3 hybridized, so these cannot be in same plane. So student X is wrong. Statement of student Y, that this molecule can have cis trans isomerism. We know that the criteria for any molecule to have cis trans isomerism was that it should have carbon double bond carbon, and also it should have two carbon atoms which are directly attached with different groups, like AB and AB. If there will be two A atoms attached with C, that this double bond containing molecule cannot have geometrical isomerism. So it must have two different groups attached with it. So in these types of molecules where there are rings, now let me just explain this one first. What do you think, that is it cis or trans isomer? Is it cis or trans isomer? It's a trans isomer because similar groups are on the opposite side. And if you want to get cis isomer, then you have to have two identical groups or atoms on same side. And how that is possible? By the rotation of carbon double bond carbon, and for that you have to break the pi bond. Now, so in this case, you can rotate carbon double bond carbon and can make another isomer, cis isomer. But when you will rotate this one, what do you think, that you can have any other structure or any other isomer? No, because this carbon double bond carbon is part of this ring, and in this ring we cannot rotate these two carbon atoms. That is why it cannot have cis trans isomerism. So both students are incorrect. So that is why option B is the correct option. Question number 26. The drug cortisone has the formula shown. This is the formula. Then, in addition to those chiral centers, marked chiral centers, like these three are marked chiral centers, how many other chiral centers are present in the cortisone molecule? Now, whenever you are finding chiral center, just keep it in mind that you are finding a carbon atom that is directly attached with 4 different groups or atoms. So first of all, eliminate all those carbon atoms which are in this form. It means that carbon is directly attached with 2 hydrogen. So this carbon, this carbon, this carbon, these all carbons are directly attached with 2 hydrogen atoms, because there are 2 same atoms. That means that this carbon cannot be a chiral carbon. So eliminate all these carbon atoms, 1 2 3 4 5 6 7 8. So these are CH2 carbon atoms. We will eliminate this. Then the carbon atom which is attached with any other atom by using double bond, it means that it is not even attached with 4 atoms. It is attached with one atom with double bond. That's mean that cannot be a chiral center. So eliminate all these double bonded carbon atom. Alright, now the only carbon atoms which are left are this one, this carbon atom, and this carbon. So these three carbon atoms, like if you will focus on this carbon, it is attached with one group, then this one is a different group, this complete chain is another group, and this one is another group. So it is attached with four different groups, and same goes for this one and this carbon atom. So 1, 2, 3, these are 3 carbon atoms which are chiral, because these are directly attached with 4 different groups. So option D is our correct option. Question number 27. Butene reacts with cold dilute acidified KMnO4 to give product Y, product X, and butene reacts with hot concentrated acidified KMnO4 to give product Y. Which statement about product X and Y is correct? So first of all, we will discuss that what are these product X and Y. Butene, when it reacts with, when this butene will react with cold dilute KMnO4, it will oxidize, and this carbon, double bond carbon, will break and it will convert into OH group, and this is diol. But when you will react this butene with hot concentrated KMnO4, then this double bond will break and these two parts will attach with oxygen, because KMnO4 is a very strong oxidizing agent and you're now using hot concentrated KMnO4. So in the presence of these drastic conditions, this will break and this carbon will attach with one oxygen and this one will also attach with one oxygen, and you will get these two products. CH3C, this carbon is attached with double oxygen and this hydrogen will be attached with it. So this is our product. And this hydrogen will further, this bond will further attach with one more oxygen and you will get these two products. So this is ethanoic acid and this one is glycol. Now, which statement about product X and Y is correct? Both product X and product Y will react with 2,4-dinitro phenylhydrazine, 2-DNPH. So what do you think that both product X and Y, whether they can react with 2,4-DNPH or not? Surely these cannot react with 2-DNPH, because 2,4-DNPH can only, this is basically a test to identify that whether in our solution there is aldehyde or ketone. If there will be any aldehyde or ketone, then precipitates will appear, otherwise there will be no change. So because this is glycol and this is ethanoic acid and none of these two are aldehyde or ketone, so there will be no test with this agent, right? So therefore both product X and product Y will not react with 2,4-DNPH. that is why this is the incorrect option. And neither product X, so this is our correct option. They are saying that neither product X nor product Y will react with this reagent. That is why this would be our correct option. So option B is correct. Question number 28. A sequence of reaction takes place. The major product is compound C. This is compound C. What is compound C? Alright. Propanoic acid, when it undergoes the reaction in the presence of this strong reducing agent, it will reduce. This is our propanoic acid, CH3CH2 COOH, 3 carbon containing carboxylic acid, and when it will reduce, you will get alcohol, CH3 CH2 CH2OH. So this is our propanol. Now on further reaction of propanol with concentrated sulfuric acid, which is water absorbent, or we can say that it is dehydrating agent. So it will dehydrate this propanol. And how that is possible? That one OH will remove from this carbon and one H will remove from this carbon. So the one hydrogen is removed from this carbon and the OH is removed from this carbon, and in result you will get this product, CH3 CH double bond CH2, propene. Our compound Y is propene. Next, compound Z. The reaction between alkene and steam over phosphoric acid, we are passing steam with the help of in the presence of phosphoric acid, which is acting as a catalyst. Now the reaction of alkene with steam, reaction of alkene, this is our alkene, and you're reacting it with steam, which is obviously water. Whenever you will have unsymmetrical alkene, which is that where carbon carbon double bond are attached with attached with different number of hydrogen atoms or different groups, this is unsymmetrical alkene, and this is unsymmetrical reagent. When these two reactants are present, then you have to apply Markovnikov's rule, where the negative part will attach with the negative part of the unsymmetrical reagent will attach with that carbon where there are less number of hydrogen atoms, and definitely the hydrogen will attach with that carbon of carbon double bond carbon, which is already attached with more number of hydrogen atoms. Now that is why this hydrogen will attach with this CH2 and OH will attach with this second carbon, and in result you will get this product. Sorry, this was CH3. Now CH2 single bond, sorry, CH2OH. No, it was opposite. We are attaching OH with this carbon and hydrogen with this carbon. This is our final product. That is why the option D is the correct option. So propane 2-ol, its name is propane 2-ol. Question number 28. Which statement is correct? Bromoethane reacts with sodium hydroxide to form ethene as major product. Okay, so bromethane reacts with sodium hydroxide to form ethene as major product. All right, this is bromoethane, CH3 CH2 and Br. This is bromoethane. When it will react with sodium hydroxide in the presence of water, like in aqueous solution, then you will not get elimination reaction. We will basically have a substitution reaction where OH, being a stronger nucleophile, will replace this Br, and after this displacement you will get alcohol as the product and sodium bromide is our side product, right? That is why we are not getting ethene, because this is substitution reaction, not elimination reaction. So option A is incorrect. 1-chlorobutane reacts more rapidly than 1-bromobutane with sodium hydroxide at the same temperature. Now the only difference between 1-chlorobutane and 1-bromobutane is the bond between carbon and chlorine, and the bond between carbon and bromine in these two molecules. Now we need to know that which one is stronger bond. This bond is comparatively stronger because chlorine is a small atom and the bond length between carbon and chlorine atom is small. That is why this bond is going to be stronger bond. So if it is strong bond, it is difficult to break this bond and it will take much more time. That is why this option is going to be incorrect. Then hydrolysis of tertiary halogenalkane, bromo tertiary halogenalkane, or you can say that it is because it has 3 carbons, so it is propane. So hydrolysis of this tertiary compound occurs mostly by the SN2 reaction. It is incorrect because we know that SN2 reaction is a single step reaction, and it is occur when you will have primary halogenoalkane. Secondary halogenoalkane can give both of these reactions, SN2 or SN1, and tertiary halogenoalkane will always follow SN1 reaction because it will make a very stable carbocation. So that would be the first step to get carbocation, and then on the next step you will have a nucleophile that will attack on that carbocation, and this is how we will get the final product. So option C is also incorrect. Option D, primary carbocation is less stable than the tertiary carbocation. It is correct because tertiary carbocation, where carbon is directly attached with 3-methyl group, and we know that these alkyl groups are electron donating. So if something is electron deficient, and there are few groups which are directly attached with that electron deficient group, and they are providing electron to that electron deficient group, that will make this compound, this ion, very stable. So in tertiary carbocation, there are 3 alkyl groups which are providing electrons or donating electrons to that electron deficient carbanion. But in primary carbocation, just like this one, where we have this alkyl group, which is one alkyl group that is directly attached with this carbon, and it will make this carbon, electron deficient carbon, stable, but not as much as this tertiary carbocation can. That is why we will say that the option D is correct, that the primary carbocation is less stable than the tertiary carbocation. Therefore option D is correct option. Question number 30. In the hydrolysis of bromoethane by aquasodium hydroxide, what is the nature of attacking group and of the leaving group? Right, now the hydrolysis of bromoethane with the help of sodium hydroxide, that is basically an SN1 reaction, because bromoethane is a primary halogenoalkane. So primary halogenoalkane can give SN2 reaction because of their less stable carbocation. So CH3 CH2 Br, it is bromoethane, and the attacking group in sodium hydroxide is OH negative, which is a nucleophile. It will attack on this carbon atom that is partially positive, and in result this bond will break, and bromine, being more electronegative, will attract this electron pair towards itself. In result, what will happen, that you will get this product CH3 CH2OH, which is alcohol, and bromine will leave as a bromide ion, and it has that extra electron pair on it. So you can identify that this is a nucleophile, and the leaving group is also the nucleophile. So the correct option would be D. Question number 31. X is an organic compound containing carbon, hydrogen and oxygen only, which means it is an organic compound. The table shows the observation made from 3 chemical tests carried out on X. Okay, so the first test is with sodium. If you will react sodium with this X, and the observations are effervescence, which means that this compound X is reacting with sodium and producing a gas. And from all organic compounds, alcohol and carboxylic acid both can react with these alkali metals to produce salt, and along with that you can get hydrogen gas. Similarly, for carboxylic acid you will get a salt, and along with that we will get hydrogen. So this indicates that it could be alcohol or carboxylic acid. Now the second test is with sodium carbonate. From organic compounds, carboxylic acid can react with sodium carbonate to produce carbon dioxide and hydrogen, because it is an acid. So its acid can react with metal carbonate to produce salt, water and carbon dioxide. So this indicates that it would be a carboxylic acid. So X has carboxylic acid, that is for sure. There is one functional group confirmed. Now the third test is that if you will react X with potassium chromate, like any chromate, it could be sodium chromate, which is a strong oxidizing agent in the presence of hot H positive, which is basically acid. So there will be no change. So in actual, uh, when you will use this oxidizing agent, then tertiary alcohol will not give any reaction. Primary alcohol, secondary alcohol, these can oxidize and convert into aldehyde and respective ketones, but this tertiary alcohol cannot be oxidized. So it's mean that there are two things. One thing is that there is alcohol. First test indicate that there is alcohol or and carboxylic acid. Second test confirm that there will be carboxylic acid group, and the third test confirm that there is alcohol, but that alcohol should be tertiary alcohol. Now what is the structure of X? Structure of X could be it should be one which has both of these functional groups. So carboxylic acid, option A has carboxylic acid, it means that it is correct, but it has secondary alcohol. The carbon atom is attached with two groups, two further carbon atom, it means that it is secondary alcohol. For tertiary alcohol, the carbon which is directly attached with OH group, it should be attached with three other carbon atoms. But this is secondary alcohol, and this is aldehyde, and this is secondary alcohol. So both of these are not present in our structure of X. That is why this is also an incorrect option. And option C, this is aldehyde, which is not correct. But this is alcohol. As you can see that in this alcohol, this carbon atom which is directly attached with OH is further attached with three carbon atoms. So this is tertiary alcohol, but because there is an aldehyde group, that is why it is not our option. Option D is the correct option because carbon is directly attached with three other carbon atoms. That is why this alcohol is tertiary alcohol, and this is carboxylic acid. That is why this would be our correct. Question number 32. How many moles of oxygen gas are needed for complete combustion of 1 mole of this compound? And this compound is tertiary butanol. Right, so we will only balance this equation. Our reactant is C, which has 4 carbon. Just for simplification, I'm writing this formula in this way, that I'm writing its simple molecular formula: C4, H, 9 and 1, 10 hydrogen and 1 oxygen. So this is our tertiary butanol. And if you will react this 1 mole of tertiary butanol with oxygen, and because you can see that it is complete combustion, definitely you will get carbon dioxide and water. If there will be incomplete combustion, then obviously we will get carbon or carbon monoxide along with carbon dioxide. So this is complete combustion of tertiary butanol. Now how we can balance this this equation, that here we have 4 carbon. Start with the balancing of carbon, you will get 4 carbon. On the product side, hydrogens, we have 10 hydrogen on in the reactant side, and we need to write 5 here to balance the hydrogen. Then oxygen, how many oxygen we are having in the product side? 5 and 4 to 4 into 2, 8. So 5 and 8, 13. So there are 13 oxygen, and we have 1 and 2, only 3 oxygen in the reactant side. So what we need to do is that simply write 6 here. So you will get 12 oxygen, and 1 oxygen is already present in our reactant. So this is how you can balance this equation. So what do you think, that what is our correct answer? The correct answer is A. Then in which pair will each compound give a different visible result with alkaline iodine, aqueous iodine? Now it's very simple. As you know that alkaline iodine, the reaction with alkaline iodine means you're going to form an iodoform test. It's basically an iodoform test, and you can easily identify any compound, organic compound, whether it will give positive iodoform test or negative. So it should have this functional group, or any alcohol that can oxidize to give this methyl carbonyl compound. Now option A, There are two compounds, and we want to distinguish them with the help of iodoform test. This is ethanol, and this is our aldehyde, and it, because it has two carbons, so it is ethanaldehyde or acetaldehyde. So this aldehyde have this has this structure. It means that it will give us an iodoform test. And this primary alcohol, when you will oxidize this primary alcohol, you will get this aldehyde. So it is ethanol, and you will get ethanaldehyde when you will oxidize this alcohol. So if you will oxidize any alcohol and you will get this group CH3 along with carbonyl group, it means that this alcohol will also give an iodoform test. So both of these structures, both of these formulas are giving iodoform test, positive iodoform test. It means that you will get CHI3 in your product, which is yellow colored solid. Now we know that because both of these formulas, both of these compounds are giving positive tests, so we cannot distinguish them. That is why it is wrong option. The option B is where you have this aldehyde. We have already dealt with this one. It will give positive iodoform test. And the second one, this is ketone, which has this formula CH3, C double bond O, CH3. And as you can see that this was our criteria to get the positive iodoform test. So this ketone is also having this structure. It means that this ketone and this aldehyde both will give positive iodoform test. So we cannot distinguish, like if you want to distinguish them, it means that one should give positive test and the other will not give any test with this alkaline iodine. So this is the wrong option. Then the option C is where again your now this is carboxylic acid and this one is an ester. Now this carboxylic acid, it should be like when you will have this structure should be a ketone that will directly attach in this way, that this carbon is directly attached with CH3 group, or it could be an aldehyde. Carboxylic acid will not give any positive test, iodoform test. So that is why this will not give any iodoform test, and also esters cannot give any iodoform test because it does not have any CH3 group, methyl group. So both of these will not give positive iodoform test. It means that still you cannot distinguish these two. So there will be no apparently the visible difference between these two tests. So it is again the incorrect option. The option D is where this is our ethanol and this is this definitely this is ethanol and it will give positive test. And what is this? This is an aldehyde, but this aldehyde has 3 carbon and the third carbon is attached with carbonyl group and 1 hydrogen. This is propanaldehyde. This propanaldehyde does not have this structure. It does not have methyl group that is directly attached with carbonyl group. It means that it cannot give positive iodoform test. It cannot make this iodoform. So if there is no iodoform, it means that you will not observe yellow PPTs. So that is why one is giving positive test, other one is not giving any test with this alkaline iodine. That is why this option D is our correct option. Question number 34. Which reagent gives a positive result with propanone? Now, propanone is a ketone which has this structure CH3, C double bond O, CH3. This is propanone. Now, alkaline iodine, as we have just discussed in this question number 33, that it is an iodoform test. When you will react your organic compound with alkaline iodine, you can form CH I3, which is iodoform, and it has yellow color. So yellow colored PPTs will absorb if you will get positive test. So this is ketone, and in our last question we have already discussed this one in this option B, that this will give positive iodoform test because it has CH3 along with this carbonyl group. So this will give positive iodoform test. So option A is correct. Now option B, ketone cannot give this positive test, this aqueous bromine, it is basically bromine water test for the identification of alkenes from reddish brown to colorless. That was its observation. Felling's reagent, it is a mild oxidizing agent, and it can only oxidize aldehyde, and it will give you reddish paper taste. And then Tollin's reagent, which was also called silver mirror test, and it again, Tollin's reagent is also an weak or mild oxidizing agent. It cannot oxidize ketone, but it can oxidize aldehyde. So these all cannot give positive test with ketone. Question number 35. Esters can be hydrolyzed with an alkali, aqueous alkali, or an aqueous acid to form two products. The table compares the two methods. Which row is correct? So what is hydrolysis? How we can hydrolyze ester with the help of aqueous alkali and with the help of aqueous acid. So if you have this, let's suppose you will have this ester, and if we want to hydrolyze this in the presence of acid, then H positive and OH negative in aqueous solution. H positive will attach with this oxygen and OH negative will attach with this CH3 to make these two products, CH3 C double bond O and OH, and this CH3 and OH will combine to get CH3OH, which is an alcohol. And this is a reversible reaction. So this is acid hydrolysis. But if you will hydrolyze this in the presence of a base like alkali, like it could be any alkali, for example sodium hydroxide, then what will happen, this product, after the hydrolysis, initial hydrolysis, this product where you are getting this carboxylic acid, it is an acid, so it will definitely react with base sodium hydroxide. So what would be the product? That acid and base, these two are reacting, and definitely these will give us a salt and water. So what would be the salt? This part with negative oxygen, this will attach with this sodium which is positively charged, so you will get CH3 COONA, a salt, and H and OH will combine to give you water molecule. So these two are the products. But this reaction where you're getting salt and water, this is a irreversible reaction. There is no equilibrium reaction between these two. So if you are hydrolyzing ester in the presence of acid, then there will be an equilibrium. But if you are using alkali to hydrolyze ester, then this is an irreversible reaction. Now this is what they're asking in these two columns, which row is correct. Now aqueous alkali, in aqueous alkali, complete conversion to acid and organic acid. Now in acid aqueous alkali, you are getting this one product, alcohol. When you are hydrolyzing this ester, you will get alcohol, and this will further hydrolyze to give us a salt. So these are the two products which you are getting when you are hydrolyzing in the presence of alkali. One is salt and the other one is our alcohol. So there must be an alcohol, like organic acid, no, we must have an alcohol in our product. So this is alcohol, and also we are getting a salt, and this is a complete conversion. It is not a reversible reaction. So aqueous alkali will hydrolyze our ester to give us alcohol and salt, and it is a irreversible reaction. So this statement is correct. And the second statement about the hydrolysis in the presence of acid, where you're forming an equilibrium mixture with organic acid and alcohol. So this was our acid hydrolysis, where there were two products. One was carboxylic acid and the other one is alcohol. So and there is an equilibrium reaction. That is why this option C would be the correct option. Question number 36. Structural isomers only should be considered when answering this question. How many compounds with molecular formula of this one are primary halogen alkanes? Now we know that What are isomers? Isomers are those with the same molecular formula but different structural formula. And we need to know that how many primary halogenoalkanes can have this, can follow this molecular formula. Primary halogenoalkanes means that in which whenever you will have primary halogenoalkane or primary carbocation or primary word containing compound, it means that there is a carbon which is directly attached with the functional group, like in this halogenoalkane, where we are having this Br as a functional group. This is attached with this carbon, and this carbon should only attach with one carbon or no carbon if you want to make a primary compound. So this is the rule of primary, or this is what primary compound is. Now I will draw the first possible structure of this molecule where there are 5 carbons. So we are drawing structural isomers. So it could be one where all these carbon atoms are in straight chain. So this is one possibility. And the other possibility is that, just keep it in mind that you are having this group same, because this is the criteria of being primary, like our functional group that is attached with one carbon, and that must attach with only one carbon. So this will remain same. You can change this chain. How we can change this chain? Like in this way, that split this chain, break it, and keep these 2 carbon in that straight chain, and I'm taking this CH3 on this carbon. So this could be another isomer. Or what you can do, that you can take this CH3 on this carbon. So 1, then if you will have CH3 on this carbon, 2, if you will have CH3 on this carbon, then 3. There are 3 possibilities. Or there is one more possibility, that if we will have this part will remain same, there is no change in this part. Now you can attach these remaining carbons with this carbon in this way, that 1 CH3, 2 CH3, and 3 CH3. So this is also having 1, 2, 3, 4, 5 carbon. So these are 4 possible isomers which we can have for this molecular formula. So so the answer is A, 4. So these are the 4 isomers: 1 straight chain, 2 and 3 where you are just changing the position of CH3 group, and the 4th one is where you are making this as tertiary carbon. Question number 37. Compound Z is formed by the reaction scheme shown. This is our compound, which is ethyl bromide, and we are warming it with potassium cyanide. So there is reaction between this reagent, potassium cyanide, and this is our reactant at high temperature. So what will happen, that cyanide being a strong, very good nucleophile, it will give a substitution reaction. So bromide will lift, and you will get this product, which is CH3, CH2, and cyanide, which has carbon triple bond nitrogen. And in these conditions, at high temperature, when you will react this cyanide in the presence of dilute hydrochloric acid, it will undergo hydrolysis. Hydrolysis means in the presence of, you will break any molecule in the presence of water. So when this cyanide will undergo hydrolysis, this part will break and it will attach with oxygen and hydrogen, and this will convert into, so this is convert into propanoic acid. And this nitrogen, when it will react with hydrogen to give ammonia, and then further you can react it with acid to make ammonium salt. So this is our main product which you will get here, and its name is compound Z. So the formula of compound Z is D. Question number 38. Hydroxyethanol is heated under reflux with an excess of acidified potassium dichromate, which is a strong oxidizing agent until no further oxidation takes place. So you will have excess and very strong oxidizing agent. What is the skeletal formula of the organic product? So this is our reactant, and this reactant, which is hydroxyethanol, hydroxy and ethanol. Ethanol means it has aldehyde, and on the other side it has alcoholic group. So OH and CHO. So we know that when you will oxidize alcohol, primary alcohol, you will first of all get aldehyde, and if you will further oxidize aldehyde, it will convert into carboxylic acid. So this is what is going to happen in this case, that OH will convert into COH and then CH2, and then this aldehyde, it will oxidize into carboxylic acid, so you will again get COH on the right side. So this is our product where the carbon is attached with 2 carboxylic acid. Now we need to identify the skeletal formula of our organic product, and that is this A, which is clearly mentioned that there is CH2 group and these two COH group are attached with this carbon. So this is our correct option. Question number 39. The formula shows the repeat unit of an addition polymer. This is our addition polymer. What is the correct name of monomer from which this polymer is made? Now, this is an addition polymer, and we know that the monomer should have double bond. So to get the name of the monomer, we need to know that what is its structure. We can get the structure by knowing the structural formula of this polymer. I'm just drawing this polymer. This carbon is attached with 1 hydrogen and 1 CH3. So 1 hydrogen and 1 CH3. This carbon is also attached with 1 hydrogen and 1 ethyl group, CH2, CH3. And these bonds are further attached with another monomer. Now we know that these monomers will attach with each other by breaking those double bonds. So we will again make this bond, and we will get our polymer. Now, what would be the name of this polymer? We will count the number of carbon atom in this chain. So 1, 2, 3, and these two, it's mean 5 carbons are in this chain. And from which side we should start giving them the numbers? If you will number from this side, let's suppose you will start counting from this side, then 1, 2, 3. So our double bond will present on the third carbon. And if you will start counting from this side, then the double bond will present on the second carbon. So it's better, according to the rules, that we should start numbering from that side where the double bond or functional group is present on this smaller number. Then 1, 2, 3, 4, 5. So this is the correct numbering. So according to this numbering, because it has 5 carbons, so its name is pentene. But we need to mention that what is the position of double bond. So that is why we will write pent2ene. So this is our correct option. Question number 40. The infrared spectrum of a compound is shown. Okay, so this is our transmittance, and this is wave number on x-axis, and we have this table. And the question is, which functional group could the compound contain? So this is the IR spectrum of our compound, and they want us to identify that what could be our compound name or homologous series. So alcohol, option 1, and carboxylic acid, option 2, then ester and nitrile. All right, so one thing is very clear, that this is a very common peak in our spectrum. Most of the time they will give you the compound with carbonyl functional group. So this is of carbonyl functional group at around 1700. So this is one peak which is present in this spectrum, and the second very prominent peak most of the time will be the peak of OH group. or the peak of OH of carboxylic acid. So if there will be a broad peak, then it's mean that there are chances that there will be alcohol or carboxylic acid, because carboxylic acid has peak a broad peak from 2500 to 3000 region, and the hydroxy, which is the group of alcohol, it should have peak from 3200 to 3600. So these are very broad peaks. So both of these peaks are absent in this spectrum, so it's mean that we cannot have alcohol and carboxylic acid uh, as our option. Then ester. Ester, the functional group of ester is that it can have carbonyl peak, and the other peak will be the peak of this carbon oxygen bond. Now you can see that the this spectrum has the peak in this region, which is the peak of carbonyl group, as you can see here. This is the region, and this peak is present, and the other peak should be the peak of carbon oxygen bond for this ester, and for this ester the peak of carbon oxygen bond should be on 1040 to 1300, and that is also present. So it's mean that our correct option is ester, and the option D was nitrile, which should have the peak at 2200 to 2250, and there is no peak in this region. That is why the nitrile is not present. So this is it. This was the last MCQs. Have a good